Today, we'll study about the pass transistor characteristics. The pass transistor will be classified into two different types of transistors. The one is NMOS and another one is PMOS. The NMOS switch or PMOS switch we can say. This is a one simple NMOS. So now here we are giving the input. The gate will control the input to the output. So that is when your NMOS will be switched on, then the gate is VDD, or we can say when gate is equal to 1 or 5 volt. Let me say VDD is nothing but a 5 volt. Now the output, the maximum the output this NMOS pass logic can able to deliver how much in the sense VDD minus VT. So now let's consider the VT equal to, let's consider the threshold voltage, that is always for NMOS threshold voltage is nothing but 0.2 times of VDD actually. It's nothing but I can say VTN is equal to VD is 5 volt, then it's supposed to be 1 volt. Now what will be the maximum voltage? The maximum voltage, the V out max or V out can able to deliver the range of how much voltage? From 0 to, that is from how much? From 0 volt to, from 0 volt to VD minus VTN. So VD minus VTN in the sense 5 minus 1, that is 4 volt. Now how it will work in the sense I need to pass a voltage in the input. When I give low logic value, in the output I will get the low logic value. When I give high logic value, the output I won't get the high logic value, the output will be degraded. So what is the meaning of that here? So let us say, let me explain. In the input, so now let us put that thing like this. Let us put a precise. This is our V in, this is our V out. I'm going to use different. So input is 0, next input is 1.5, then input is 2, then input is 2.5, then input is 3, then input is 3.5, then input is 4.5, then input is 5 volt. So these are the input order I'm going to give. As we know, this transistor will be turned on. So further what will be VDD is equal to 5 volt. I already applied the gate, that is whatever VGS. This is VGS, right? VGS is equal to 5 volt. That is normally we'll say. Now when Vin is equal to 0, what will be your V out? V out is equal to 0. When I give Vin is equal to 1.5, my V out also will be 1.5 I'll get. So my Vin is 2, output also will be 2. When Vin is 2.5 volt, output also 2.5. When Vin is 3, output also will be 3. When Vin is 3.5, output also 3.5. When Vin is 4.5, but you can see here, my input is high logic, about high logic 4.5, right? In the sense, output will get us how much? We won't get 4.5. The output is degraded due to threshold voltage effect, that is the maximum it can able to deliver how much? 4 volt only. So I will get 4 volt. Even 5 also I'll apply 4 only. Due to this, I can say the NMOS can pass strong 1 and weak 0. This is the complete summary we can make for our NMOS. The NMOS can pass strong 1 and weak 0. This is about NMOS. So now, same now what I can do, now if this one pass transistor, if it is driving the another one more pass transistor, example, let me take an example here. Let me take an example. So first, this is our one pass transistor. Then here one more pass transistor, it is driving, right? Okay, let me put a condition as like this. Now here also one thing is, now you see this is our Vin. Vin is equal to assume as VDD I'm applying. So here, what is that? Here is VDD only. The gate is VDD. Now, how much I will get here? Actually, I will get as VDD minus VT I'll get. So it is equal to how much? Maximum of VDD minus nothing but what? 4 volt maximum. So now what is the V out here? V in is equal to VDD when I give output I will get as how much? 4 volt I will get. Now you can see even here also I will apply V in is equal to VDD. You see here also applying V in is equal to VDD. Now how much I will get? Now you can see this gate is nothing but how much volt? 4 volt. So I can say now here it is nothing but what? 4 volt minus the threshold voltage VT is equal to how much? It is 3 volt is maximum it can able to deliver here. But my input is how much? 5. So here I will get as how much volt? It is 3 volt only I will get. Even though still if you are using another one more pass transistor, if this is driving like this, if it is driving this, then when I apply the input here as Vin is equal to VDD. If I apply VDD, what is my output here? I will get as 2 volt I will get because here the gate is 3 volt divided by 2 volt. So I can say simple here I will get as VDD minus 2 times of VT. So here I will get as here VDD minus 3 times of VT actually. So each and every if one pass transistor it is driving the another one more pass transistor, then the output voltage will be get degraded by 1 by 1 actually. That is why there is a rule the one pass transistor should not drive the another pass transistor due to the output will be degraded if I connect like this. But instead of that, if I do like this, what will happen? When I connect the two pass transistor like this, so what will happen when I do in this way? This will be your VDD. This will be a VDD. Then even this also will be VDD. Now I'll say this is your input. Vin. Vin is equal to assume as VDD only. Okay, Vin is a VDD. Now we can say what is this here? Here my maximum will how much I'll get? VDD minus VT. That is I can say here I will get as VDD minus VT will get correct. In this place I will get VDD minus VT voltage I'll get. But how much I will get here? So whatever the voltage here is there, the same amount even here also I will get VDD minus VT only will get even here also. So from this we can summarize that what if you connect the pass transistor, that is NMOS pass transistor in series in connection, the output voltage will not degrade. So the example is here we can say if I apply the voltage is here around 3 volt. If I apply 3, here VDD is 5. Okay, VDD is 5. If I apply VDD is 5, how much I will maximum is 4 I will get. So when I apply Vin is 3, I will get here also 3 I will get. So but here also VDD is 5 volt only. The maximum how much it will get? 5 minus 1. Maximum is 4 volt I get. So again I'll get 3 here. So I can say the output voltage not get degraded, but here it's not in this case. So this is what we can say in the pass transistor, how it will work. So now next what we will do, let us study about the PMOS pass transistor. So for PMOS pass transistor, PMOS pass transistor. Now let's see PMOS pass transistor. Now let us draw the PMOS pass transistor first. This is where PMOS. So I will connect this. Now this will be your V in input. This is what actually, this will be your, this is your VSS actually. PMOS should be connected to VSS. As you know, then only your transistor will be connected, switch on, correct? So we have to connect to VSS. Next, this will be your V out. How much I will get out actually? The out will be, I will get as VTP, because the transistor by default, what will happen? VSS it is on. So V out is equal to VTP. So from this, what I can say, for low logic level, when I give low logic level here input, when I give low logic, I won't get not proper low logic. Not proper low logic here. But when I give high logic, that is input high logic, then I will get as high logic. Means when I give input is equal to 0, it won't pass as 0 here. Why? Because the output range is, here I will say, the output range is from VTP to VDD. But in case of NMOS, what is output range? The output range will be 0 to VD minus VT. But here VTP minus, sorry, VTP to VDD means when I give 0 also I will get VTP, I will get, I won't get as 0. That is why I can say when I pass 0, I won't get exactly as 0. But when I give 5, I will get exactly as 5 I will give. Let us go for an example here. This will be your V in, this will be your V out. Let us say 0, 0.5, then 1, 1.5, then 2.5, then 3.5. Next, next is 4.5. Next is 5. So example now, when my input is equal to 0, what will be my output? I will get exactly, my output will be how much? Minimum is VTP. So I will get voltage as 1 I will get. When 0.5 also, I will get as 1 only I will get. When 1, it is 1 only. But 1.5, I will get as 1.5. When 2.5, I will get as 2.5. When 3.5, I will get 3.5. When 4.5, I will get 4.5. When 5, I will get as 5. So from this, we can summarize the PMOS transistor. First, the PMOS can pass strong 1 and weak 0. This is a very, very important point you need to remember. Always we can say the PMOS can good at passing in strong 1 and weak in 0. And the same the way in NMOS, it is good at passing in strong 0 but weak in 1. So individually with the PMOS and NMOS, we cannot able to design any circuits due to the output degradation. So that is what you have to do. You have to go for the transmission gate. You have to go for transmission gate. The transmission gate can able to deliver the entire range of voltages. That is transmission gate. The transmission gate, how it will be? The transmission gate is nothing but the combination of PMOS and NMOS. So this will be your PMOS, then this will be your NMOS. So example, this is your PMOS, then this will be your NMOS. Now both you have to connect like this, cascading, you have to parallel, you have to connect here, even connect this also. Now what will happen? This will be your V in, this will be V in, this will be your V out. Next, this will be your S, this will be a S bar, example, okay, this will be a S bar. Now we can say transmission gate is a bidirectional device. So I can give the input through here, I can get the output by here, even I can give the input here, the output also here. Next, S and S bar. So now I can say the very important that transmission gate can able to deliver the TG, that is transmission gate can able to deliver the entire range of input level from 0 to VDD without any degradation. This is very, very important. So it can able to deliver the full range of values from 0 to VDD without any degradation. This is a very important, the advantage of your transmission gate. But what will be the disadvantage? It will be area is more actually. The reason is here we have 2 to 1 plus 1 2 transistor CMOS. It is also a CMOS, right? PMOS and NMOS. But the additional one more transistor is required where actually there is a control signal from S to S bar. This is a S, right? So from S, what you have to do in the sense, from S you have to take, you have to connect here one inverter, you have to connect the S, then this only is connected to S bar. So the one more inverter is connected. So additional transistor we need for S to S bar. So it will give more area. Now what we'll do, let us do some numericals related to NMOS. In one numerical we'll do in the problems. Okay. So now let us say Vin is equal to 1 volt, 2.5 volt, then 3 volt and 5 volt. 5 volt, then BTN is equal to 0.7 volt, it is given, and find V out for the given circuit. Okay, let us draw the circuit. Now this will be your Vin. This is your Vin actually. Okay. Now this will be your VDD. This is your VDD. Okay. Okay. Now your output is this. This is your output. Now, what is the maximum voltage can able to derive something but VDD minus VT. For each and every pass transistor will produce the output as that. Okay, so let us go for the numerical now. First input is 1 actually. What's the V out max? We'll get the V out max is V out maximum is how much? Maximum can able to deliver VDD minus VT, that is nothing but 4 0.3 volt because PD is 5, VTN is 0.7. So 4.3 is maximum. Okay, now first let us write 1 volt. If it is 1 volt, what is that? Maximum is 4.3, so I'll get 1 volt here. Next, I'll get 1 volt. As we know, when it is series in connection, the output voltage will not degrade. Now it is 1. If it is 1, what happened here? My threshold voltage is 0.7, right? 1 minus 0.7, even this also is V in only. See, even this also. Even this also is Vn, even this also is Vn. Now, how much I'll get now? This will be Vn is 1 volt actually, right? Vn is 1 volt, even this also is 1 volt. Now, 1, the gate is 1 here, 1 minus 0.3, 1 minus 0.7 is 0.3. Now again it will go minus, so output I'll get as 0. So first what I can do? 4, right? So this will be your Vin, this will be your V out. First Vin is 1, next is 2.5, next is 3 volt, next is 5 volt. Okay. So now for 1 is how much you are getting? 0 we are getting. Okay. Next what we'll do? Let us go for next 2.5. We'll apply for 2.5 now. When it is 2.5, what I'll get? I'll get here also 2.5 I'll get. Correct? Next, here also we'll get 2.5. Next, 2.5 minus 2.5 minus 0.7 threshold voltage. How much it is? 1.8. Maximum 1.8 I'll get here. So I will get as 1 volt here because the maximum is 2.5. The gate voltage is 2.5 minus the threshold voltage is 0.7. So 1.8. So 1 I will get. Again 0 only I will get here. So again it will be 0 only. Yes. Now next, let us go for 3. Let us go for 3 now. When it is 3, what will happen? 3, I will get as 3 only. So here also 3 only. Next, maximum is how much? Sorry, here, sorry. Here the input is 2.5, right? The input is 2.5 the previous case. Input is 2.5 the previous case. So here up to 1.8 only can go. So this is wrong here. Actually, it is not 1. It is supposed to be what? 1 point. 1 point. Here I will get as 1.8 because 2.5 minus 1.8. 1.8 minus again 0.7. 1.8 minus 1 will get us 1.1. I'll get as 1.1. Here V out. Next for 3 volt. Here 3. Here also 3. 3 minus 0.7. 2.3 is maximum. 2.3 is maximum. Again here input is a 2.3 is maximum. 2.3 minus 0.7 again. 2.3 minus 0.7 is 1.6. So I will get as 1.6. I will get 1.6. I'll get. If it is 5 volt, how much I'll get? If it is 5 input is so till here I will get as 5 only. I will get, correct, because of series 5. Then here 5 minus 1 maximum is 4 volt. I'll get. So your input is 5 actually. So 4 minus 1 max 3 is maximum, but input is how much? It is 5 actually. Input is 5. So 4 minus 1, 3 volt. So I will get as the output as how much? 4 volt, not 4 volt, 3 volt I'll get. This is the numerical problem which will be asked in the examination. Like this, they may ask.